Today in Logopress, we're going to simulate the forming of this part. We're going to hang on to it over here on this back edge, and we're going to wipe this main body down, and then finally pierce through the side here with a cam as well as these two vertical holes. So it's going to be a wipe of this main body. And to get there, we're going to start cutting it out. We've got a little Z preform. We've added this tab to the blank here, and to do that, you were going to bend that downward here to hang on to the part. Same thing on the back of the strip here, actually. And then we're going to use those both as hold points to hold the part as we wipe down here so it doesn't pull everything. Then we'll cut that tab off. We will cam pierce our tab. We'll pierce our two slots, and finally we'll cut the part off. Shy today. There we go. Doing the cutting in just one main block here with little punches on the ends. These are just sticks for simulation purposes. They will, of course, be purchased punches later. And we've got our form punches here as well. The red are the form punches, the teal are the form dies, and then the yellow and the green are pads. So we are going to start ProgSim. And it's going to go through all this strip here, and it's looking for all the stuff that was created in the Logopress strip layout. And so it's going to be able to pick up that a lot of these form punches are indeed form punches, and the form dies are form dies, and that kind of thing. But we need to go through and make sure what it picked out is good, and add to it what is missing and take away what is not, as well as fill out some things it just doesn't know about. That's fun. Let's hide. I'm gonna have to hide these sketches. Can I hide that for now? No, maybe not. There we go. All right, so it's pre-populated some of this list, and then it's left gray on items it hasn't even tried to do. And then we're going to have to go through the side here and add a few more. But the main idea is that we are trying to incorporate all of the faces of tooling that is going to actually interact with the part. Everything that's going to cut it or push on it, we want represented here because this is a real-life simulation right down to gravity. It's giving... We're going to kind of start at the top here and work our way down, kind of just like SolidWorks. It's giving us some warnings at the top here, saying stuff's not defined, there's no lifters or anything like that. But there is not, then we can kind of come on down and we're going to go through the rest of the list. So we're going to start with the trim tool, and it's picked up all these cutting punches. It's identified this cam punch is not a regular cutting punch, so it's not included it. We can go to the check element tab and see that it's doing everything that we actually want it to do. Those cutting punches are there, so we can confirm it. And we can come back to the list, and we're just going to keep on going down through it. Go to the upper form. It's picked up all of these bodies because they were all created with the form punch tool. And it's actually missed the big white punch here just because I think of the way that one was created. So we need to go through and we need to remove the pads from here. So that's a pad, and that's a pad. And we are missing, we'll go into our tree here, one of these. That was made towards the end, is probably this one. Yes. And that. And again, we can go into the face selection here, or we can go into the check element and see that it's got everything. This is good, this is good, this is good. This punch was missed entirely, so we can go back to select entities. we can pick up those faces into this bottom face selection area here. And we're looking for everything that's going to contact the surface. Adding more is going to increase the computation time, but it will still work. You want to make it as minimal as possible just for the sake of performance. So we can make sure that those took. We do indeed have all of our punches now, and confirm. I'm going to skip the counter lifter for now. I'm going to come back to that in a second. I'm going to do the same thing we just did with the lower form. This is where that punch was that that form punch that we need for the upper is actually up here. So we're going to deselect that because that is, of course, on the lower. That's a punch, that's a punch. This is a pad, so we're going to deselect this. And we can see here on the selected faces, this punch has not been touched at all. And I think I'm going to want this face here too. So I'm going to go into here and pick that. And we're going to get these three. And we'll check what we have. This is good. That's good. If you were worried about the material pulling against this edge, you would definitely want this triangular face here if you were actually going to make your punch like this. But there's no reason for it to pull against that, so we're not going to bother. It's not as bad as some of the old forming simulation where an open edge was basically a razor blade and it caught everything. We'll hit confirm. We still need to do our pads. I'm going to do the counter lifter and the lifter right now. These two are linked. They're going to be the same thing unless you go in and try to mess with them, but there's no reason for them not to be the same thing. So you can double click on either of them, the lifter or the lower lifter. Makes a lot more sense to think of the lifter though. The counter lifter is more just for the software. It's going to pinch the material and hang on to it. But it's not, it's mostly just a simulation tool, but it does need to be accounted for because it cannot touch the formed areas. It's going to ask us the first time that we do it what we want to call it. I can just accept, and then we can look at this, just use normal too. And we want to draw a lifter here. We could go through and put little lifters where it's going to be, but it's better to, it's easier, it's faster and all that just to put a rectangle down on kind of the carrier and say just hold on to the carrier. It does need to be on every single station. It could use a pad in the lower and the upper instead of the lifter, but it's usually just easiest just to put some lifter in, put it down past the on your carrier straight down. It can be on the pierces where all the pilots are. It can go through cutting. It doesn't matter. It just cannot touch any formed areas. So I'm going to put this almost out to the tab over here, and I'm going to put this almost to this tab over here, and it's just going to hold on to all the material it can. It'll make it more stable. The only thing we have to do here is that there needs to be in the first station, just for the purposes of the simulation, there has to be something on both sides of the center line. For this, because the carrier is off to the side, it's not centered on the part, that means we need to add a second rectangle here in the beginning. We're going to stop it as soon as it starts forming though. We're just going to run it about there and that's fine. I could constrain this and all that, but frankly it doesn't matter. So it's added our lifter here. You can see it's going through the cutting and that's fine. It ends before the form, and this one sneaks between all the forms. Real close there. Last two things here in the tree is the operational boundary. This simulation is, I'm going to hit OK on the name here. This simulation is going to simulate your entire strip one station at a time. And so we are telling Logopress where to divide the part, where to have each simulation, each chunk be. We could just make it a rectangle, and that's fine, and that would actually work for this part. But for more complex stuff, being able to define exactly where to go to between the parts is better. We could, if we wanted to, run the boundary between it up here to try to include this pilot with this station, if that was better for what we were doing, depending on how we thought it was going to pull. But we're not really too concerned. The one thing that we do want to do here, though, and again, this is for a simulation thing, is that we want to have a little jog in the line somewhere in the carrier, and this is just to kind of lock it together. This is just a simulation thing, and I'll show you what I mean as I sketch here. So this is going to be retained here and locked here. We're going to keep it back with that. So the only thing, I could just go straight across here. And I do want it to be the full width of the strip. This is also going to define the width of your material in the simulation. So if your line was short, your material would be narrower. And if you wanted to make your material narrower or wider, you could make this line shorter or wider, and that's fine. But the only thing we're going to do here is make sure that we have this. I'm going to well back from here. So we're going to put a little jog in here in this carrier area. And what I mean by that is I'm going to go over a little bit, and I'm going to come back a little bit, and then I'm going to go down, and there's now a jog in here. And I could even jog a third time if I wanted, and I guess I just kind of want to come through between these, so I might as well. But the idea is that somewhere in this carrier, we need to prevent it from slipping. And it might be a little cleaner if you want to be perfect, is we could come in and we would only need the one bend this way. So that might be the better way to do this, is you have a little thing like this. It doesn't need to be any particular dimension. I could probably make it really tiny and it probably wouldn't matter. But we're just trying to create a divider here between the two, and we need something to trick this into not moving. So I'm trying to put this little divider in between. Oops, we don't want you. Come on. I want this somewhere in the carrier. That's all I'm going to do for it, though. That's one of those that only matters when your part is only be carried on one side, because of gravity, this part would tip without this little lock here, and you can actually play with that and watch it fall off the carrier or off the lifter if you want. Okay, the last thing here in the list is the pilots, and this is just asking for a hole where the pilots are going to be. We're piercing our pilot down here, and it's got a feature here. If I hold Control and then I select the edge of a patterned feature, it's going to grab all of those patterned features until they stop existing or are changed, and you can see it goes all the way down here because there's nothing interfering with these pilots the whole way. We can go ahead and hit OK. It's picked up the correct size from all that and everything, so it's a nice automatic there. You could deselect if you don't want to use it in some stations and all that, but those are now there. And so we've got all the basic features that it's asking for. We still need to put strokes on for the lifters, but we more importantly need our pads here. I'm going to add the upper pads first. The pads can be done individually if you want, or they can be done all together, whether or not, and like they're bolted to a single stripper or something like that. It's still going to be computed individually, so all the forces are still going to be individual, and you'll still have to put them together. So there's fundamentally no difference as long as you're making the same style of pad. In this case, these two pads are pushing against form dies beneath them, and so they could be made the same in the same single punch or same single form pad, or they could be made separately and it'd be fundamentally identical. This pad, however, is pushing against this lower pad, and so it's technically a different type of pad, and so it must be made separately from these two. So I have the option of I have to make this one pad, and then I could either make one pad that includes these two, just because it's faster, or I could make them separate if I had a reason that I wanted to play with them individually, put a ton of force on one or something like that. So we're going to start just at the beginner strip work down in order here. We're going to pick the component we want. It's smart enough, you see it picked up those faces on the bottom here in this list. We're going to tell it how much the stroke of this is. It's got an inch and 5/8. Just at the initial force, we're going to tell it we're going to push down with 5,000 pounds of force. Nope, we're going to tell it we're going to put 2,000 pounds of force on it. We're going to see what that does. And this is going to push off of this pad that is not yet existing on the lower. So there's a selection here that I need to make, but I can't yet because it doesn't exist. So we're just going to have to leave this as is. And I will confirm. I'll make one more pad just because it's faster. I'm going to make these together. 1 and 2. Just picked up those faces. Just set the initial force. We're going to put 5,000 pounds on these. These are going to have the same inch and 5/8 travel. These are indeed contacting the lower form, so we're just going to hit OK on these, and they will be good to go. And then finally, we need a pad on the bottom here that's going to hold this as we go down. So we are going to go into the lower form, or lower pad element, and we're going to grab this block. It's got that face automatically. This is only going to get 1,500 pounds. It's got 3/4 an inch of travel. Nope. And this is actually picked this up already because it's directly above it, that it's going to be pushed by, or it's interacting with the upper pad. It is not the driving tool, so it's smart enough to do that. And this one is now good. So the last thing we need to do here is go back to this upper pad. We can just double click. And this now has our lower pad here to push on. It switches to driving. I was smart enough to do that now, so that's cool. And we can confirm. The last thing I'm going to do here is I'm going to make our lifters just match the pads. That's the easiest thing to do. There's sometimes when you might not want to do that, but when you can, it's the simplest and it's most straightforward, and you'll find out when it doesn't work. I believe that is all of our pads here, all of our punches. I can add this cam punch here. So on our cam punches here, we have 3 of them: 1 for cutting, 1 for forming, and 2 for forming. We're using the cutting, of course, today. But be aware on the forming ones, it says upper cam and lower cam, but it is not talking about being lower as in attached to the lower assembly and upper as being attached to the upper assembly or the top half of the die. It is talking about which half of the or which side of the material it touches. This is especially critical on stuff that you bend all the way over. But because so this is the top side of the surface, so this is the top side of the surface. So something coming from the outside would be an upper cam. Whereas if I was coming from this side and I was hitting this side of the material, it would be a lower form because this is the lower side and it's tangent over the way to the lower. So this is the lower cam here. Just something to be aware of if you're doing those forms. But back to this one. So we are going to add our cutting cam punch. And we'll pick the body. And we'll see if it picks it up here. Oh, we need to give select the plane perpendicular to punch direction. You can usually just pick, actually it's convenient. If you make it with Logopress, you can pick the plane for it. There you go. Otherwise, you're going to have to pick, it's better pick a plane, but you could pick the face of whatever you're cutting, especially if it's coming in at a fun angle. We'll see if it picks up the sketch of that punch. It does. So we are good to go there. See how I flip that arrow by clicking on it, signify punching direction. We'll hit OK. And last we have some parameters down here. There's the press stroke. They're around 6 inches. Picked up our strip material thickness and our stroke. This is just cold rolled commercial quality steel right here, and the medium friction is you're going to be your correct choice vast majority of the time. You're going to be doing some really high lubrication to get in the low friction zone and some really aggressive nasty stuff to not have any kind of lubrication at all left. Yeah, you'd be running dry for sure. Last thing here is the kinematic. We can put it in motion, make sure it's doing what we want it to be doing. See here, my cam cutting is actually coming the wrong way, so I go in and change that. We can see our pads and everything are traveling how we want them to do. So pause that. Go into my cam trim tool. Flip that arrow that I hit before. Let's try that again. And we'll hit play. There we go. All right. Believe we are all set up here. That data not consistent just means that it's basically the results don't match the simulation stuff, and the fact that there's no results is definitely doesn't match what it's got here then. So we are going to go ahead and launch, and assuming this works out, we will dive into the actual use of ProgSim's cut optimizer to change this blank. Alrighty, so our first results are in. Looks like our punch is missing the end here just a little bit, so we'll need to shift that. But see our initial guess at a punch here, a little extra material pulling in that corner. We're trying to get that to come straight and straight. So, but otherwise, the simulation works. So let's go fix this punch. And then let's get the punch optimizer running. Well, first, let's take a look at some of the results here. You have this menu to display 8 or 10 or whatever different results plots on here. The formability is your most basic one. This is the standard. This is great to show people because it's a very finite. Can I get it onto a light spot here? Very finite result. There we go. They're just color categories. There is no wishy-washy betweenness here on the colors. It's purple. There's thickening going on. There's blue. There's compression. Green is safe. There's a little bit of stretch going on here. It's going to hold this shape real well. Risk of splits is getting pretty aggressive. Thinning happens more on the high stretch materials, and of course splits. There is no red here, so that is nice to see. Have a thickness. Show you 74 thousandths at the thinnest spot and 120 thousandths at the thickest. Can also do that as a percentage. It's plastic strain, percent of material that's actually deformed beyond spring back. Major strain, stress of the material in the main direction, and the stress in the minor direction. Together, these come up with your wrinkling factor. That's where this chart comes from here. Predicting there's going to be there's potential wrinkles here up to 0.03 on the scale, which is not that high. This doesn't mean that it's going to be wrinkled and folded over. It just means that there's forces in the area that are going to try to do stuff, and you'll often see the results in the surface, not being perfect. Assuming it's tied down well enough not to actually wrinkle. This max failure that I skipped over is actually the partner to the formability. So this is the very cut and dry. This is what it is. This is the numerical value of what this is. And it's going to show a chart pretty far through here as far as the failure and the splits go. And 1.0 on the chart is a failure. So the fact that it goes to a max of 0.84 means that we're not going to fail this part, and that's fine. But you can get a better idea of how close you are to failure. 0.8, you could push this a little farther and you'd still be fine. It's especially good to know when there is failure. Is it a 1.01 or a 1.2 or a 2.0? You could come back from something close, but when you get up here past 1, 2 or so, you need a new idea rather than just some massaging. And the last plot here is the springback. It is showing the local springback on that station. That's why you see more springback here than on this station. It's just what's happening in that station as the press closes, and the forms come back. So, and this is also compared to the closed state of the tool. So this is not measuring from your finished part. This is measuring from what this was when the die closed to the die opened. You can align the part with this springback adjustment points. So this is kind of like on a check gauge. We can say that the carrier here is going to be flat, and it'll align the part to show you if these 3 points are on the on the surface block, where's the rest of it. So we could do that again as align it. Using these as our reference points. Oops. Try this again. Yep. Reset. Do we got to drag you? That's interesting. So we can come and adjust, and that's now our reference point, and that's going off. Makes more sense on flatter parts where you're going to have that kind of thing. There's 2 main display styles. The show middle surface is the actual mesh that's being simulated, versus we can have it show a appropriated thickness for what it is. It will actually make this thicker and thinner going through here, but this is just an approximation. This middle surface is what the real simulation is running, and it's accounting for the thicknesses. Local color scale will adjust your chart here. Let's go to max failure. This will make more sense. So the default is 0 to 1.2. If you do local color scale, it'll show you your maximum is about 0.8, 0.84. So it's just going to go from min to max. And you can kind of see the range is a little more extreme now that our max is 0.8 rather than 1.2. Also useful for like thinning. New local color scale, and it'll adjust it to match. These last 2 are going to be used with our cut optimizer. We have a play option here. We can either ask it to begin playing the die at the first station and simply go through everything. There's a speed toggle here so we can go a lot faster. And we can watch it go through every single station. Toggle your tools on and see what it's doing. You can go individual tools too. You don't need to see the lifter. Turn on your upper. Get rid of that lifter. Turn off that pad. See that getting wiped through there right now. So
like I said, you can either let it go through it all, or you can just pick an individual station and hit play. And it's going to start from the bottom, so it's going to lift up and go through the lift cycle, and then it's going to go through the drop cycle. And this is just going to keep on going through this, and so it'll get to the bottom, and it'll just lift up again. It'll just show you that one station. So how you can display the tooling here. You also can display forces for the tooling. Go on the lower form here. If I check that, it's going to show how much force is on the lower form. It's 15,000 pounds being pushed against this, both from the pressure pad and from the form die. But there's 15,000 pounds on that die right there. It's 5,000 on that one, 1,500 on that one. You can turn those on and off for all of these gear cutting forces. All right, so let's go. We're going to stop this. And we're going to confirm. We're going to go fix that punch. Oh, what do we need? Let's do. Should have measured it. That's more than we need. Let's try that. Close enough, right? Okay. Let's save what we did. It's going to ask if we want to recreate everything, and frankly, this warning is dangerous. We do not want to throw out everything we didn't recreate. So we're going to hit no. We're almost always going to hit no, unless you're planning to start from scratch. There's no reason to ever hit yes on that button. So we can go to the cut it. We do want to go into the trim tool, make sure it updated our shape here. You can see this. The shape is updated. We're going to go and check element. I can't even tell. Can we measure it? We can measure it. I think so. I don't know what it's supposed to be. We're going to go ahead and assume it's good. If not, there's extra material up there, and that's fine. So we're going to go into the computation tab, and we're going to use this cut optimizer section up here. We're going to expand this, and it jumps to the last station. We are actually going to come over here to station. We want to do the station after our, so we want to optimize this form. It wipes it down and we're trying to optimize this. We want to go to the next station because we want this, the die on this to release, and this is being taken at the bottom. So we want to come over here to station 8. Going to hit the create tangent lines thing, and it's going to go around the skin of our part and create a sketch. And we're going to go into this again, click it a second time, we're actually going to go in and edit the sketch. We are going to ask it to optimize the whole outline, basically from here around the edge up to, I think we'll ask it to include here. So we're going to go here to here. So we don't want it to mess with the rest of this because it's just, you know, basically cut flat and it's fine. So we're going to delete that. I'm going to delete that, and then I can just select this chain and delete. And we're going to grab these two as well and delete. I'm going to drag this back just a little bit from the corner, and this one too, just a little bit from the corner. And this is just another software thing. It doesn't like going right to the edges. So if you pull them back a little bit, it works a little bit better. That is a 3D sketch, though. You can do just about any 3D sketching geometry you want in there and modify this if you had something in your blank you didn't like, but ours is fine. We're going to seek a deviation level here, so it just defaulted to what I used last time, which was 1 millimeter, and we are going to give it, let's try 7 thousandths. We're going to ask it to try to get this edge within 7,000s here. So we are going to hit run now that we know our simulation works and set up our edge. Alrighty, we have the results of our optimization here. We can see the tweaking it's done to the shape of our cutting punch here between current and the initial. A little hard to look at, but you can swap again. Yeah, you can see a little bit. And anyhow, result is pretty straight here. Let's see. Tell us how far we are. Yeah, in a few thousandths on most of it. The same. Yeah, it's off by 8. No, yeah, just here back on the back little corner. Pretty good though. Also look at our forces on our pads and stuff here. You can see lower pad got more force than we put on there, so it bumped it up a bit. So something to keep in mind of your forces that you apply versus what it actually increases it to actually need. So upper pad put 6,000. I put notably less than that on there. And I needed 8,000 on that second pad. So both of those should be bumped up. And ideally that you would use these values next time you simulate. So you would want to go back and punch these in to your forces here. The upper pad was like 5,000. Second one needed like 8,000. And the lower pad was like, what was it, 4,000. So it would need that. And then the other thing we got to do here is we actually got to update our cutting geometry. There's a little tool it gives us here if we go into the cutting punch here. I'm just going to edit it in context and look at the sketch. So we've got our actual geometry here, but now we can bring in the optimize the cutting punch outline command. It's going to bring in a polyline for it, which is basically a mess. But first thing it wants us is, do we want to use the whole thing, the whole pink thing? So do we want this outside? You can trim it off and reuse your geometry from before, or you can just hit confirm and just let it update to your new geometry, and that's fine too. It's more important to maintain your back geometry here. If if your punch is already in a tool, you would definitely want to maintain as much as you can. Or if you're already at the end of your process here, you'd also want to maintain that. But frankly, if we're still refining our die here, it's okay that it's not perfect. That do it? I miss that. No? Yeah. Looks like it's going around. Let's exit. Show prop. Open contour. Doesn't like something right here. Oh, well, that's fun. There we go. All right. So now we got our new cutting punch on there. As normally, if you don't
cut right on your skeleton, you're going to end up with schnibbles in your punch. So the one thing we're going to do here is I'm going to isolate. Oh, gotta get out of this first. I'm going to isolate this form station here, or the skeleton of it. You can see all this little stuff. Just we're not quite on it anymore. So what I'm going to do here is going to go into it. Looks like I was already trying there. So we're going to change our body delete. Yeah, this must have been for the first one. And I'm going to pick. Where are we here? Strip skeleton pattern. Alright, solid bodies. Clear this. So I picked all that, and then I'm just going to depopulate the 3 that I actually don't want. And hit delete. And then lastly, oops, we can get out of exit isolate. We can get out of edit. And yeah, all right. So we're already good there. So now you can go back into the simulation again and use this new optimized punch here to refine it more. We can get closer than the 12 thousandths or 8 thousandths or whatever it said there. You could run it through again. You could go through this and optimize the shape of this and get all your lines and curves in there with the optimizing command, or just changing the backend to make sure that works better. You probably want to check your punches over, but that is the idea. And be sure to save.